Hi everyone, in this video we'll talk about several topics including ATM, AL5, MPLS, IntServ and DiffServ. So before starting, let's talk about a concept called label switching. It is a kind of switching that uses labels of fixedness to select states in switches that can indicate how to switch packets, and it has several benefits. So first, let's talk about asynchronous transfer mode. It uses short fixedness package to carry information through the network, and it can minimize delays for civilization for some sensitive traffic, and it has high simplicity and concurrency. Well, what if we have the applications with smaller data units? It will cause potential waste and delay. And so what should the fixed size be? Well, initially it has 53 bytes, but in practical, we use 64 bytes, 53 bytes mentioned before, and 13 bytes for the overhead, which makes it easier to implement. So here is the cell structure for the ATM. As we can see that there are 5 parts for the header. So here is the ATM protocol stack. We can see that both ATM layer and ATM adaptation layer, which we'll talk about further, all belong to the data link layer. So ATM once has a dominant share, but why it finally failed? Mainly because that it cannot satisfy quality of service, especially for the time. And ATM was once used as a high-speed alternative to Ethernet until Ethernet caught up, as we can see from the picture. Also, ATM left his legacy called the MPLS. So ATM has several adaptations. These adaptations can support information transfer protocols, which are not based on ATM, and AL5 is the dominant one. It has no cell encapsulation, and in AL5, particle level CRC can detect all kinds of errors, including noise, missequencing, and duplication with high probability. So let's talk about MPLS. It means multi-protocol label switching, which is sometimes called tag switching. It is initiated by the desire to send IP over ATM. And both MPLS and the ATM share some similarities, like they're both label switching, and they both has hierarchy of labels, but they are also different in some ways. So how does the MPLS work? Well, it pushes, as we can see from the middle, it pushes the label on the packets as packets into the network, and the label is then used for switching within this network. And finally, it is popped off the package depart to the destination. So, let's talk about RSVP. It is kind of integrated services which provide two guarantee services and control loss services. And RSVP is separate from the routing protocols, which simplifies in itself but hinders the ability to provide quality of service guarantees. And one thing that should be noted is that RSVP is designed at the outset to support group communication. So there are 4 types of RSVP message. There are a path, resources, tier that can release the resource before the timeout, and error messages. So RSVP scales well in terms of the source overhead, but it scales poorly in terms of switch overhead. And generally speaking, RSVP functions better at the edge of the network, where there are few flows. So finally, let's talk about DiffServ. It is a simple and scalable architecture that can simplify manage network traffic and provide quality of services on IP networks. So just like the ARRs in MPLS, labels in the domain forward transit traffic to interim node towards the destination. The label will mark locally generated traffic, which may also be implemented by the source. And here is the comparisons between IntServ and DiffServ. So that is all about this video. Thank you for watching.